All right. Hi, folks. Thanks for joining us today. This is the third webinar in our Ensuring Quality Heat Pump Installation series. So today we're going to be looking at the quality attributes of a heat pump installation. We'll just get started right away so that we can take advantage of the full hour together. Just want to move ahead slides there, please, Rob. Perfect. So the Community Energy Association, we acknowledge that we carry out our work on the traditional and ancestral territories of Indigenous peoples. So through our commitment to truth and reconciliation, we support First Nations, Inuit, and Métis communities in taking climate action and reaching their goals of energy sovereignty, security, and resilience. So I'd just like to begin our session today by acknowledging the Indigenous peoples from all of the diverse and beautiful places we are joining from. So I'm joining from what is now called Nelson, but for thousands of years, Nelson has been the traditional homeland of the Snayaks Nation, the Silks Nation, and the Ktunaxa Nation, and is home to the Métis and many diverse Indigenous peoples. So I just like to acknowledge with deep respect and gratitude that it is in thanks to their generations of stewardship that we're able to enjoy these mountains, forests, and waters in the way that we do. So the next slide there, please, Rob. So Community Energy Association, who are we? CEA is a registered charity and nonprofit committed to accelerating bold action by local governments and Indigenous communities related to climate and energy. So we have an unwavering commitment to our clients to provide services and support them on the journey from awareness to plans through to implementation. So what does that have to do with kind of training around high performance building? Well, in BC, existing buildings are the second highest emitters of greenhouse gas emissions. So to us, building better is a climate action. All right, next slide there, please. So the Kootenay Clean Energy Transition, or KCET, is a project that was developed to address shifts happening in the energy efficiency, renewable energy, and home comfort space. So through KCET, we want to help Kootenay and boundary communities prepare for a more energy efficient and healthy future through capacity building and training sessions like this one. So thanks to the generous support of the organizations you see listed at the bottom of the slide there, we're offering this free workshop as part of that piece. So we do have a great selection of workshops coming up, and you can find more details at our website at communityenergy.ca/built-environment. We've also have recordings of the past couple webinars in this series. So once I've finished with this introduction, I'll put that link in the chat there for those folks who missed it. All right, I'm just going to pass things over to Rob, but wanted to cover a couple housekeeping items. If you have questions as we go through, we do encourage you to raise your hand, and Rob will answer your question right then and there. We'll also have time at the end of the session for your questions, so you can put them in the chat too as we go along. As you would have noticed when you logged in, we are recording the session, and we'll be sharing the recording and slides with everyone here via email within the week. It'll also be posted at that website there at the bottom of the slide. So lastly, for those of you collecting continuing professional development points through BC Housing, we will be sending out a confirmation email of your attendance within a week. All right, so it's with great pleasure that I introduce Rob Pope, a senior consultant with Ecolighten Energy Solutions. Rob has vast knowledge and experience in the HVAC industry and has been involved with installing and servicing energy efficient systems since day one. So a huge thanks, Rob, to you for joining us today and sharing your wealth of knowledge with us. So I'll pass things over to you.
Thanks, Jenna. And thanks everybody for being here. The general topic of this session is quality attributes of a heat pump installation. That can mean a lot of things. So I'm going to do that in the context of the entire journey that for new construction and for retrofits that it takes to ensure a quality installation, or at least give you the best fighting chance of getting that. So this session, we're going to cover heat pump technology and types first, and then preparing for an installation, reviewing quotes, what is a quality installation, and finally commissioning and performance. First of all, just, and please forgive me, probably all of you, if not most of you, know this already, but I'm just going to emphasize what a heat pump is. there is no end of interpretations that I see. So I just want to make sure that we're all clear. A heat pump simply just moves heat. It either moves it, it captures it from one place and distributes it to another place. So in the winter, it's capturing the heat from the air that's outside, and believe it or not, no matter how cold it is, there's still heat from a heat pump point of view in the cold air outside. It takes it, it concentrates it from outside and delivers it inside. So that's how it works in the winter. In the summer, it's doing the opposite. It's taking that heat from inside and dumping it outside. Um, One of the things that is interesting to a lot of people is that air conditioner, well, that's a heat pump, except it only does it in one direction. So technologies, if you're considering getting a heat pump for a project or for your house or for somebody's house, um, there's different technologies out there. When I first started working in the industry, there was simply the single stage heat pump, which is full capacity on or off. They're still out there in the market. They're the least expensive, but they have the most inefficiencies and other issues like noise and things like that. But it's still out there in the market. Probably won't be for much longer. At some point along the way, probably 3 decades ago at least, two stage came along, and we all thought, oh, here we go. Well, we got it all sorted now, because you don't need the full capacity all the time. We have a peak condition in the winter. In some places that might be as long as 3 weeks. Other places it might be just a week or less. Um, and uh, Summer is the same situation. The peak that you design the heat pump for, or the heating system and cooling system for, is not most of the time. Most of the time we're in shoulder seasons, and therefore we don't need the full capacity. We want a percentage of that capacity. And so when heat pump technology evolved so that we can have two stage or two speed heat pumps, we were all pretty happy with that because it's a lot more efficient. And then not too long after that, they'd been around in Asia and Europe for quite a while, but they finally came to North America. They were the variable refrigerant flows, sometimes called variable refrigerant volumes, VRV systems. All that means is that outdoor unit sitting in the yard, that the compressor out there is not on or off like a single or two stage. Even a two stage is on or off, just in different stages. Variable um, modulates. It modulates up and down, and it load matches. So it sneaks up to the load requirement of the building, so the compressor is quietly coming on to match the load and modulates according to the load during the cycles. Extremely efficient, a lot more quiet. And the other benefit of that technology is you can have one outdoor unit and multiple indoor units, sometimes referred to as a multi-split. So it really revolutionized um, the way we look at heat pumps for homes. And then more recently, not that long ago here in North America, particularly in Canada, believe it or not, um, heat pump technology advanced with those VRVs that we were just talking about to adapt to colder outdoor temperatures. Heat pumps generally have been, and depending on the heat pump, still are um, dependent for their efficiency and their capacity, how much heat they can deliver on the outdoor temperature. The colder it is, the less capacity there is and the less efficiency there is. However, with the cold climate heat pump, they figured out a way to deliver full capacity and full efficiency to sub-zero temperatures. And to illustrate that, just look at this graph here. A blue line, that blue line represents a standard heat pump, single or two stage. Um, it starts at 47, 48 degrees Fahrenheit. That's the starting point. That's the gate from which all heat pumps start. That's the nominal capacity. So you can have 3 different types of heat pumps, like in this case here, all say 4-ton heat pumps. There are 4 tons at 48 degrees Fahrenheit. As soon as the temperature drops, their capacity, they're no longer 4 tons in some cases, their capacity drops and their efficiency drops. So your standard heat pump drops quite rapidly, as you can see. By the time you get to 30, 32 degrees, 0 degrees Celsius, you've run out of capacity and efficiency, and you have to back that system up with something else. So you have to provide supplemental heat. With the VRVs, as you can see, that curve is a lot shallower. And so that heat pump will provide more capacity and more efficiency for a longer period of time as it gets colder outside. With the cold climate heat pumps, you can see that red line. It's flat. It's flat until you get to somewhere around 5 degrees Fahrenheit. And before it starts to drop off. And when it starts to drop off, it drops off in a very shallow curve. You still have 87% at -4 degrees Fahrenheit and 75% of -13. That's quite substantial. And the efficiencies kind of ride that same curve. They don't drop off so dramatically either. And so it's a great solution for cold climates, which is practically all of this country. So that's the technologies. And then equipment. There are many types of equipment. In general categories, heat pumps come in air to air. That's the most common throughout North America, air to air heat pumps. But there's also air to water heat pumps. So air to water heat pumps transfers that heat it captures from outside to water instead of to air. It's usually used in a radiant system. And it can also be used, you can take hot water, put it through a fan coil and create hot air or chilled air. And you can, in a lot of cases, preheat your domestic hot water with that air to water heat pump. There's also domestic hot water heat pumps. They come in 2 general types. That's the self-contained package unit that you put in a mech room or furnace room, and it's all self-contained. What would be outdoors is right on the unit. And then there's the split systems where it's like a normal heat pump. The most common version of that is the Sandon heat pump, usually used in passive homes. It's a split unit, but it doesn't do any space conditioning. It just does domestic hot water. And then ground source heat pumps. Geothermal systems are referred to. They're water to water or water to air. So they're taking a liquid that you're piping through the ground inside pipes and transferring the heat from that liquid that it captured from the ground instead of the air and delivering it either to water, as in an air to water heat pump, or to air, as in an air to air. But today we're going to focus on the air to air systems. And by the way, if you have any questions or comments, please feel free to just jump in. So types of equipment. We've got ductless mini splits, and they're pretty common in most parts of Europe, Asia, and Eastern Canada. They're all over the place. We see them very common. Not as common in BC yet, although that's changing. So those are the cassettes that mount on the wall. Sometimes they can be ceiling cassettes mounted between joists, just flush with your ceiling. And sometimes they can be sitting on your floor against the wall. There's different kinds of cassettes. They're all cassettes. The thing that they all have in common is that they don't have any ducting attached to it. So it really works well, for example, if you've got a forced air system, but that room above the garage was never warm enough, or that loft upstairs was always too hot. But you don't have enough ductwork to get there without opening up walls and ceilings. That's a good solution to add on to the forced air system, is put a ductless cassette in that area. It works It's a great fit if your home has radiators, in-floor electric hydraulic baseboards. Um, the only issue with these, and you got to be really careful about, it happens in retrofits often. So you got a radiant system, an old boiler, and you want to get rid of it. You don't want the radiant, you want air, you want cooling, you want to be moving air around. But you can't open up the whole building. It's not in the budget, and you're not prepared to do that. So you put ductless splits, these cassettes on a wall. Problem is that cassette can only heat or cool the room it's in. It can only do what it sees. Now it can move down a hallway if it's not too far, but it can't make right turns and go, through doors to the next room over. That next room over, maybe it's bedroom, needs its own. So it can add up to take care of each of the rooms. So you got to be careful about that. That's a lot of moving parts and cost and refrigerant lines, condensate lines, wiring, and so on to put many cassettes in the house. Most common thing seen in BC, across North America, in fact, is the central ducted system. That's the most common type of heat pump installation, whether that is that indoor unit is a fan coil only, all electric. It's just using the heat pump for its total heating or cooling, or it's using the heat pump with some supplemental electric strip. Either way, it's central. The other, um, probably still the most common form of that is a gas furnace that has a coil connected to the heat pump in the ductwork of the furnace, right off the top in the plenum. If you've got an existing forced air system, it's the best way to go. It's a pretty economical way of heating. You get cooling out of it as well if you didn't already have it. So that's the equipment and the technology.
Hi, Rob. Sorry to interrupt. We just had a couple of questions come through the
Sure.
chat, and I thought that as you
Yeah,
finished up that session, it might be a good time to bring them in. Sebastian just asked, if you get a heat pump, do you need an HRV system?
it's a good question. It depends. If it's a new house, absolutely you do. It's crazy not to, and you're required to have ventilation because the house is going to be tight. You need some way to do a balanced ventilation in the house. If it's an existing home, it's a different set of metrics that you got to consider. As you think about this, say you're replacing just your heating system. It's broken down, and you're going to put a new system in, and you're going to put a heat pump in. Um, if you're not doing any other upgrades to that house is, and if it's an older house, that's probably a leaky house. You wouldn't know that unless you did a blower door test. You wouldn't know precisely how leaky it is. But if it's a drafty house, your HRV is not going to do you any favors. It's not going to do anything. It's just going to be moving air in and out of the building. It's already um, a building that's already moving a lot of air in and out. It's not going to add any efficiency, save any efficiencies. But if the house gets tight, if that building envelope doesn't leak that much, and the only way you can know is a blower door test. So, if you test at, say, 5 air changes per hour or less, then a heat pump is a really good idea. You should put it in. If you're at 3.5 air changes or less, then you absolutely need to consider a heat pump. Otherwise, it'll get stale and stuffy in there. It won't be a good air quality in the house.
Sorry, sorry,
I'm
you
sorry,
mean
HRV.
H?
HRV, yeah.
Okay.
Yeah, sorry, HRV, yeah.
Perfect. Thanks, Sebastian. Let us know if that answered your question or if you have any follow-ups. Meredith just comments, Rob, you mentioned that ductless units are not great for whole home heating, but we are successfully using ductless units for primary whole home heating in both new and retrofit contexts. I think we should talk about this today, as we are happily heating medium-sized homes with ductless units.
Well, yeah. So here's the calculation that I always make. Um, if it's a new home, especially, you know, um, you need to manage air quality, so you need an HRV system in there anyway. So you got to put ducting around. You uh, also want to filter the air well if you can. So you want to MERV 8. We like to put MERV 11 or better in the houses. So you need the ability for that air to overcome the pressure drop from that a good filter to provide indoor air quality in the building. And then it's moving ducting around. That's usually the issue. Ducting, in a lot of cases, if it's not well coordinated, creates drops and furred walls and that kind of stuff. It imposes on the aesthetics of the building. And so in those cases, often the option is to put in ductless um, cassettes. Now, when I then that's a good way to go if it's understood that each one of those cassettes requires its own refrigerant lines, its own condensate, its own wiring. Each one of those cassettes is a bunch of complex moving parts compared to ductwork, which is dumb and simple, right? Um, in when you have enough rooms, so you got a 3-bedroom house, for example, there's 3, you got a living room, there's 4, right? If the living room, dining and kitchen are attached, maybe you can get away with 1 there. You got a rec room, there's 5, and on it goes. By the time you start adding that all up, you got to think, is this really worth it or not, right? Because like I said, you got a lot of moving parts. You got a lot more vulnerabilities that you would have compared to a centrally ducted system. Now, sometimes that all works out from a cost benefit point of view. And if it does, then yeah, sure, it'll work well, right? There's nothing wrong with it as long as that cost benefit works out. What we encounter most often here in BC is that people don't like those things. They don't want those things on the walls, right? In a new construction, especially. That is the most common barrier that we face. They just don't want to see those things on the walls. Uh, Paradoxically, in Ontario, that's a very common thing. It's, very different culture there. People don't mind those things as much as they do here. And maybe that's because they've been there longer. There's more of them in other parts of the continent. And that might change here in BC, but right now that is one of the common barriers.
Great, thanks, Rob. And we do have a couple other questions coming in just about comparing different types of heat pumps and efficiencies. But I think that just to keep things moving along, if we have time at the end of the presentation, because we're just kind of getting into now the attributes of a quality heat pump installation. So maybe we'll save those questions till the end. We do have some planned time for questions, but I just want to make sure that we do have time to get through the presentation as well. So folks, keep putting your questions in the chat. And we'll get to them after the presentation. Thank you.
Thanks, Jenna. So like anything, you can't really isolate one part of a process um, and talk about its attributes like the installation, unless it's in the context of a process that works to support the optimization of that part of the process. You want to optimize the um, installation, quality of installation. You need it to be part of a quality process, right? And this is the process. First is discovery stage 1. That's when you find out what's important, budgets, that kind of stuff. Stage 2, you need to do some analysis, so an inner guide evaluation is pretty critical, which will include a load calculation, a block load in a existing home. That's all you need. But if it's a new construction, you need load calculations done. Then there's an equipment selection process, cost of the equipment and the technology that's most appropriate for the project and so on. Then you want to design. Now in a new build, that's an actual design. It's a blueprint, drawings, pointing out where ducting is going, its sizing and all that kind of stuff. In a retrofit, it's at least this is the plan. This is the specifications. This is how we're going to take that system out and put the new system in. And this is what it's going to look like. This is where we're going to put the outdoor unit. This is where we're running the refrigerant lines and all and so on. The installation itself, we'll talk about that more later. There's a few things that are critical in general to all installations, and we'll go into more detail about that later. Performance verification, it doesn't matter how well installed a system is, you have to make sure you do the shakedown. We find out where all the bugs are. If there's anything that needs to go back to the supplier for warranty, you want to know it as soon as possible, and you want to check what you had for performance targets against what you're actually now delivering. Is it actually delivering those performance targets or not? And then finally, the home owner education. You hand the system over and you equip the homeowner with the information they need for warranty, for service, maintenance, how to use the system, and so on. And we'll go into that in more detail later as well. Um, Discovery is pretty critical. I really would not anymore take on a project unless I went through this process. In new construction, it's often referred to as IDP, integrated design process. It's a fancy word for just getting everybody together. That's all it is. In new construction, before you start building the building, you want to explore all the options that get you the best bang for your dollar for your budget, deliver the expectations of the homeowner and all that stuff, where you can still coordinate things like structure and architectural design and all that kind of stuff before you're cornered into less choices, right? Just get everybody together, homeowner, and go through things like budget and expectations and aesthetics and all that kind of stuff before you start installing. In retrofit, it not quite the same process because there's already a system there. So you're kind of, stuck with what you can do to that system, or maybe you can't do anything to it. So it's basically um, working with the system that's already there. And what you want to do in that case um, is make sure that the system can deliver the airflow you need to put that heat pump in, right? The heat pumps are pretty finicky, right? You got to have the right airflow and you got to make sure that duct can do it. The most common issue is ducting is not sized adequately. It's not big enough, right? There's things you can do about that, but you got to check that. That's really important. The electrical panel capacity, you might have a 100 amp service, but you need, now you need another 40 because that you didn't have before. Maybe there's room on the panel, maybe not. You really got to check that out. It's a big deal. And envelope performance and air tightness. You want to get an energy advisor in there if you can and do blower door test and check the building for other things like its insulation values and all that kind of stuff, especially on a retrofit with the intention of improving the building itself. You might be changing that heating equipment out because you're doing other things. You're going to tighten up, weather strip here and there. You're going to blow some more insulation into the attic. Maybe you're going to change the windows. Those things have to be considered um, in concert with your HVAC system replacement. You've got to take into consideration how the building's going to change so you can properly size the equipment. And of course, if there's somebody who's been living in the house, it's perfect. You get insight. You can say, "Oh, how's the system been running?" And you might find out a lot of things. It just comes on with a bang every time the fan starts blowing. There's a bang in, behind the wall in the hallway outside the kid's bedroom. That'll tell you something. If you're an installer and contractor, that there's some oil canning going on there. It's probably a pressure related issue. It's technical. We don't need to get into it, but it gives you insight. They can tell you where the hot spots and cold spots are. They can tell you how drafty it is. They can tell you about the air quality they have and the air quality they'd rather have, all those kinds of things. And that really informs the way what you propose to replace the system with. An inner guide evaluation is pretty straightforward. You do a blower door test, you find out how drafty the house is, but you also investigate, the level of insulation, basically the energy performance of the building as is. And then there's A good energy advisor will give you really good advice on, cost benefit if you just do this to the walls or the windows or the attic or weather stripping, how that will change the energy performance of the building itself. They'll also do a what's called Hot 2000 model. And all that is modeling the energy performance of the building. But what it does, it gives the homeowner or whoever wants it a block load calculation of the heat loss of the building, right? Which then can be used by the contractor to size their equipment. In preparing for a heat pump installation, here's some of the initial considerations. Obviously, what we're doing in this business, in this industry, in the heating industry in general, heating and cooling, is we're delivering not systems, we're delivering comfort. We're delivering comfort in the winter when it's cold outside, you're warm inside. When it's hot outside in the summer, you're cool inside. Comfort also means indoor air quality. It's fresh and it's clean air, right? That's also comfort. And it's also comfortable not to spend more money than you need to, so we want to hit the sweet spot for people's budgets, give them the best bang for their dollar. So that's part of it. Electrical panel service, as we discussed, we want to make sure there's enough room on the panel. Can we do it with the panel size that's existing? In new construction, we want to make sure that there's enough service being contemplated to incorporate the the extra amperage draw of heat pumps.
Perfect. And we just, I see Eduardo has his hand up if you want to unmute yourself there and ask your question. Oh, you're
Okay, biggest question is, you talk about how sizing the equipment according to the energy advisor. And my experience so far has been that the energy advisor never gives that number. Okay,
Never gives it out?
nope.
And
They just show a report with percentages, never say the house is losing so much heat. Never.
okay, well then you just
Never say how much energy you need to produce with heat pump, especially
Yeah.
not on the heat when the peak happens. Let's say in the middle of January when it goes really cold, how much heat you need to provide at that particular point.
Okay, well
And
that's sorry, go ahead.
And the second one is air quality. Air quality is not usually based on I imagine PM 2.5 or PM 10, but air quality is crucial with CO2 levels, and CO2 levels are never measured. Those are the two issues that I think need to be addressed when it comes to sizing equipment and air quality indoors.
Right, so on the first issue, that energy report belongs to whoever commissioned that energy advisor to do the report. Now, what you're saying, it's not my experience. Energy advisors generally are happy to hand it over to whoever asks for it. Whoever paid for it owns it. And so it's not something that, that this should not be an issue. You should just hold out your hand and get it and distribute to whoever you like. So I think that's a non-issue. You just got that, demand it.
I'm not saying that they don't give me the report. They give me the report, but the amount of energy that is needed for the house is not reported. It's not reported in the report. I have the report. The report is given to me because
there's
work
more
with
than
house.
one. Yeah, there's more than one. There's a lot of information. For them to give you any report at all, they have to have done an energy model. Right.
Yes, and it's never the amount of
that
energy
energy
that
model
doesn't.
will have the loads on it. So you just have to ask for that, right?
I never get it.
Well, that's okay. So that's a different issue then. But I've never seen that as a problem, and most of the time, energy advisors aren't even asked for it. But there's no reason for them not to give it to you. There's nothing sensitive. There's no, it's not like a secret or anything like that. It's an easy thing for them to produce for you. and that you should expect that and not be content with not getting that information. So that's one thing. On the air quality, yeah, you're right. There's a lot of issues with indoor air quality, especially when the house gets tight. A tight home needs air moving. It's not just about replacing stale air with fresh air from outside. It's about managing all the air in the building, because the HRV is only injecting a certain amount of fresh air into a fixed volume, which is much larger than the volume of air the HRV is moving. That recirculated air,
No,
just
but
like in
I'm
an
talking
airplane.
about the measurement of the CO2 levels to maintain them below 1,000 parts per million. Not because right now the HRVs are controlling the air quality with humidity. That's the sensor that says how much humidity and they increase or decrease amount of air. It's never controlled with CO2 levels, which is the critical part. The PM 2.5 and PM 2.10
Uh-huh.
are filtered. So, but the CO2 is produced inside the house, and the HRV is never controlled by the level of CO2 in the house.
Well, that is an option to do that. If you put CO2 sensors in the house independently, in most cases, we find that with only some exceptions, the CO2 levels are fine. With a house whose mechanical system was reasonably well designed and executed in its installation. If you have, first of all, the HRV is running on continuously. It can be bumped up in speed for sure when there's a humidity gain or for other reasons. Um, if you have a reasonably good filter rate or better, and you one of the things that we like to do is put a UV light into the plenum. All these things combined tend to provide indoor air quality that does not exceed the CO2 levels. But it's good to monitor it, and that is an option. You can actually have that HRV operate based on CO2 levels. Okay, so comfort and experience electrical panel, existing distribution system. Again, in a retrofit, you don't want to assume that the ductwork is adequate. You want to make sure that it is. There's things you can do if it's not. There's any good contractor, mechanical contractor, or HVAC contractor will know what those things are. Like, for example, you could put an extra return in on a wall that is common to the furnace room and the hallway, for example, just to relieve some air. There's a few things you can do. It's important that your contractor knows how to incorporate recommendations from your InterGuide report. That's one thing. And the other thing is it designs a system that will be installed to meet your needs, right? So the best way to make sure that happens is you talk to your contractor how you're going to accomplish this. Sizing should be based on proper heat loss and heat gain calculations of the home. Aesthetics is pretty important for most people. How it looks. You can have extremely ugly installations. I've seen them all, right? So you want to know, where's that heat pump, how the refrigerant line is going to run from that heat pump to the indoor unit or units. How are we going to get through the walls? Where do we have to make drops or not? How are we going to do this, and is it acceptable or not? Your outdoor placement. There's a few things that are really important to consider when you're thinking about where to put that outdoor unit. So things like your manufacturer's required clearance. You need good airflow. You want to protect it from strong winds and snow accumulation. For example, you don't want to put it right below an overhang that's going to dump snow off your roof onto the unit. And then there's a few other considerations. Depending on the municipality, there's things like egress for fire, easements, property setbacks. There's also, a lot of people invest a lot in their outdoor living areas, so where it goes based on those criteria is important too. And noise issues, you want to make sure that you're not going above. In a lot of municipalities is 45 decibels, at the point of reception, in other words, your neighbor's property line, you know, you can't exceed that. So you want to make sure the heat pump's at a spot where at that property line to your neighbor, it's not above the 45 decibels. Also, there's things like, you know, how long can you run those line sets, right? Some products have a maximum limit to the length of the line set before you have to, you know, either relocate the outdoor unit or mitigate it with other technology if it's too long
I
of
got
a
a
line set.
question on that.
Sure.
So we are wondering about putting an indoor coil that is quite far away. Do you have to do a reverse inverted trap so you don't get liquid slugging coming back to your compressor?
It is
Hi-
not
hi.
recommended. Yeah, it's not recommended to do that. First thing is to make sure that you're within the maximum line length from the manufacturer, right? Often on a typical city lot, that's easy to do.
Well, we have a job in Roslyn. That's
Yeah.
like a 3-story building.
Uh-huh.
Ductless split they want to put in. It was built at the ski hill, I don't know, 10 years ago or something. Want air conditioning now, but the one indoor head is going to be 60 feet away.
60 feet up.
60 feet up.
Up.
So we're
So that's the issue, is that you've got a grade difference, right? You've got an elevation.
yeah. So we're just wondering
difference.
about piping
Yeah.
practices that you would recommend in
Yeah.
this.
So there is you can get the problem is that the oil will separate out of the refrigerant, right? So you can get a device to prevent that from happening, to mitigate that. A lot of, like, for example, Carrier has one, Train has one, York has one in their installation manuals. You'll see that in the long line length considerations that they have these components, and what you'll realize is most of them are from the same manufacturer, so they're independent of the brand, like Carrier, for example, and Train, and they're different brands of furnaces, as you know, but that component is made independently of any of those, so you can get them for pretty well any installation. So there is.
Do you know what the name of it is? Because I'm not familiar with this.
Not off the top of my head.
Okay.
Yeah, not off the top of my head.
Okay.
The most available resource for that I can think of is in the Carrier Bryant literature, when there's a line set length set of considerations. So they don't just give you those components, they give you what your efficiency drops are, because when you have that situation, you're above the maximum. You don't just have that issue with the oil potentially separating from the refrigerant, but you also have an efficiency drop, a capacity drop. So
Yeah,
it
you
works those
you
things
don't
out
want to
for
go
you too.
outside of the limits of the line set length. I get that. Yeah.
More or less, that's the easiest thing to do, is stay within the max. And different manufacturers have different maxes. And you take, for example, a Mitsubishi or Daikin, and you can go 160 feet, right? So it depends on the equipment as well. Okay, budget. Getting most of budget, of course, you know, that goes without saying. Don't have to speak much about that, except for two things we don't want to happen is to spend more money than we need to deliver the expectations that have been asked for, obviously. But we don't want the other situation, where the homeowner wanted something, didn't know they could get it when we're happy to pay for it, right? You know, but they didn't realize it was something they could have. So you want to make sure you hit the sweet spot on the budget. Noise is a big thing. It's not just the outdoor unit, it's the indoor unit as well. Obviously, inexpensive single stage heat pump is going to not cost much at all. It's be easy on a budget, but it'll be noisy as hell. Different manufacturers have different grades of product for different budgets, you know, and obviously one of the things that gets compromised in less expensive systems is noise. So it's critical to check those dB ratings and make sure that it's going to be acceptable. Supplementary heating. If you're using a cold climate heat pump, you might not need any. But one of the things that we do have to clear up is what that even means. There's a lot of misunderstanding in the terminology. Supplemental versus backup heating means this, is that if you have a heat pump sized to meet a percentage like 80–90% of the load of your winter design condition, and there might be a week or two where it's not capable, you're going to need to supplement that or provide auxiliary heat. In other words, you're boosting that heat pump's capacity with another form of heat. Electric strip typically, right? That's supplemental and auxiliary heat. Backup heat is a different thing, or emergency heat. That's the system fails for some reason, especially critical in remote locations. I brought my family up on an island. Getting parts and that kind of stuff was not easy. So it was pretty common practice, whatever kind of heating system you had something to back it up 100%. So it could be, it could be a gas furnace, or you could size the supplemental heat to do the full load. It's backup heat or emergency heat. Different thing.
Rob, I just wanted to jump in and let you know that we just have about 10 minutes left in
Holy
the
geez.
hour.
Okay. I'm going to go quickly here. Review the quote with your contractors. You got to make sure you got actual model numbers in there. No, a quote that says, I'll give you a heat pump or a furnace, right? But it doesn't say what the manufacturer, the size, or the model number is crazy. You need to have that information so that you can do some verification and check on it. Do your own little research, because you can Google that number, that model number, and find out all kinds of stuff. And you want confirmation of rebates if there are rebates available. If there are rebates available, you want to make sure you can deliver what you need to deliver to get them. But if they're not, you will want to make sure you don't promise that there'll be a rebate when there's none available. And for example, the Canada Greener Homes Initiative is no longer accepting new applicants. Load calculations. There's not enough that can be said about load calculations. They're pretty critical. If you don't know the heat loss or heat gain of the building, you know nothing. It's just pure guesswork, and it's a pure coincidence if it works. And the evidence of that is the amount of issues that plague the industry because heat loss and heat gains weren't done, or they weren't done properly. So if you Google for the Kootenay region, what is the BTU required per square foot to adequately heat or cool a home? These are the answers you'll get on the internet. You can see they're all in the range of 20–22 BTUs per square foot, right? That is a rule of thumb. And unfortunately, there are too many times where the rule of thumb is what's used. Now, if say we take that same rule of thumb and we apply it to a house in Nelson with a 51,000 BTU heat loss in step 3, and say a 34 and change heat loss in step 5. That is the calculated heat loss. That is the properly calculated heat loss using the code compliant CSA F280-12 methodology. So for this step 5 home, if you were to apply the rule of thumb, guess what will happen? Here's what you need, here's what you get. There's a huge difference, massive difference. We see this everywhere all the time. It's a problem across the continent, actually. Big problem. So you don't want rule of thumbs. Review the quote with the contractor for warranty. What is the warranty? Not just for the equipment and manufacturer's warranties, but what's the labor warranty as well? And what's the potential extra cost? Does it or doesn't it include upgrade to the electrical panel, right? Does it or doesn't include, I'm going to take off the drywall here, but I'm not going to patch it, or, you know, those kinds of things. It's not that you expect your mechanical contractor to do everything. You want to know what other costs are involved in getting it done. And a quote should separate labor from parts and equipment. Just like we talked about, the actual installation, good practice, make sure that the entire length of the refrigerant line is insulated. That's pretty critical, like from beginning to end. And all penetrations through the building envelope through your exterior wall from outside to inside or vice versa is sealed properly. Those two sets of issues that I see a lot that haven't been adequately done in the field. Also matching controls. I don't want to get into it too much, but the best thermostat is the one that's made for the heat pump, the system. So if you have a, you know, a Lennox system, there's probably a Lennox thermostat that is best for that, and so on. The manufacturers have their first tier products, usually have proprietary controls, right, that optimize efficiencies and performance. Third-party thermostats, especially these so-called smart thermostats like the Nest and so on, which are actually pretty dumb, are not the best. In the installation, you don't want to see this. You see that refrigerant line there? It's barely covered, and you know it's a pretty ratty looking refrigerant line. What you do want to see is something like this, nicely, neatly, and thoroughly covered. You don't want to see this envelope penetration. That's just a, you know, that's just a disaster waiting to happen. What you do want to see is this, properly sealed. It really makes a difference. It's really important that at least these kinds of things are dealt with.
Rob, there's also one other thing in the refrigeration kind of world here that they've discovered, that sealing the end of the line set insulation with some silicone or some tape so moisture can't get in the ends can actually help prevent pinhole leaks, because they're finding that there's a lot of refrigerant leaks that they're not able to source, and what they're finding is the moisture getting into the insulation going into the line set there, I can turn video here, is causing the copper to break down, like you see the discoloration in that copper line. So
Yeah.
best practice would be actually put some silicone on there or tape for everyone's
Yeah,
knowledge.
at the end the copper should never see the air on a refrigerant line at
Yeah,
any
so
point.
seal
Yeah,
the end
yeah,
of it to prevent that.
yeah.
And anywhere you cut, if you're cutting like to do a bend, then make sure you're sealing that for air tightness too. You're not just shoving it in the wall or whatever.
Yeah, thanks for that. You got to confirm that your ductwork will accommodate. We already talked about that. Condensate management, you know, to put those condensate lines. Sometimes you got to put in, like in a ductless, you need to pump. You don't have an adequate route using gravity to get rid of that condensation, so you're pumping it out. You just got to make sure that's all thought of and taken care of ahead of time. And filtration. The standard recommendation is MERV 8, but I can tell you in my business, we never go below MERV 11. We're always, MERV 11 is our default. That's the minimum we're willing to go. For one reason, it protects the equipment. For the other reason, it's good, better indoor air quality. And we usually, almost always, advocate for and put and design into our systems a UV light, which means you need a 4-inch filter rack, right? Not a 1-inch, what we call rock catcher. That's not good enough. Commissioning the system. You can't just turn it on and walk away. You got to test it. You know, you got to test the system. We got to measure the airflow. Is we getting the right airflow? Measure the pressure drop. You know, measure so that you can make sure that your fan speed selection is correct. You've configured everything right. The controls understand each other. There's no leaks. There's no leaks in your refrigerant. There's no leaks anywhere. You got to do the shakedown of the system just in case Two, there is a potential warranty issue. The component derived from the supplier, you put it in and it doesn't work. Now you got to take it back. Get that sorted out in commissioning. Don't wait for the homeowner to discover it later on, you know, on a cold night in the middle of winter on a Sunday evening, right? You don't want that to happen. And you want a commissioning report. A lot of manufacturers require startup checklists, right? You got to go through. And then there's industry checklists you can get. In other words, if I'm a homeowner and I'm getting a system installed, what I want is hold out my hand. Let me see the paperwork that you've done your startup and commissioning properly, right? There's no lack of forms from the manufacturer directly or from the industry that easily to access. As you can see to the right, there's tons of them. There should be a commissioning report. And I think finally here, this is pretty important. I can't tell you how many times I've gone to a project or a job that had issues, and all it was, the homeowner had no idea that if you programmed it this way, that it, you know, it was going to take longer for it to get the heat up in the mornings, or the programming schedule was off, or they didn't know they needed to change a filter. It was filthy and blocking airflow. They didn't know that, you know, they got the outdoor unit and they got pine trees all over the place. You got to, you know, a couple times a year, you know, clean those pine needles off that thing. There's a whole bunch of stuff. Where the filters are, how often to change, and what kind of filters, where to get them from. Here's your paperwork for warranty. Here's the commissioning checklist. Here's the user manuals. Here's the maintenance regime that you should be thinking about having us or somebody else do. Here's how to operate the system here. You know, here's the thermostat and how to do, you know, your programming and what's the difference between auto and on for your fan setting, for example. There's a whole bunch of that stuff you need to go through with the homeowner before the job is really done. And that's it.
Great, just in time, 1 minute to spare. I know that we do have a few questions left. We'll maybe tackle one or two here, but recognizing that folks need to get off the call, I am just going to run a feedback poll. I know that you are all familiar with this now. Just lets us know what we did well and what we can do better next time. And we really do take into consideration all of your feedback as we plan out future sessions. All right, so we did, as I mentioned, it's just at the beginning there, we did have questions about the different efficiencies of different systems. Any comments on ductless units versus central regarding efficiencies and also zoning benefits? I know you touched on that a bit, but
Yeah.
maybe the zoning
The
benefits.
zoning benefits are pretty clear with the ductless splits. You know, you got one in this room, another one in the other room. They're completely independently controlled. So it's a nice clean way to get zoning. The actual efficiencies are the same, you know, because the delivery of the energy, so basically however you're delivering the heat or the cooling into the building, is going to be the same whether you have ductless or ducted central air system. The efficiency depends on the technology in the equipment. Of course, you can mess it up. You can mess anything up, right? You know, and lose efficiency if you don't install it right or design it correctly. But otherwise, the efficiency is the same. But you can zone in the new construction. We do this very often. We zone with zone dampers and controls with ductwork. You know, we provide independent control. It's not as clean. It's a little more clunky than putting ductless splits in each of the rooms. We just find that we get a lot of resistance to that ductless split idea. But if you can do it, it's a clean, easy, simple way to get good zoning. Either way, the efficiencies will be the same.
Great. Thanks, Rob. And maybe we'll take one more question. And what I'll do, folks, is I'll look back through the chat and any questions that are throughout that we haven't answered. I'll touch base with Rob and just provide some more insights when I follow up with the slides. So I'll just take one more here. How do concealed ducted heat pumps attic units compare to ductless in terms of efficiency?
Efficiency is the same. Um, Concealed units we put in attics, you know, that they're have different static pressure restrictions. Attics, top of walk-in closets, for example, crawl spaces, tight spaces. It's nice because you can do ducted systems without having it all emanate from one central source, and therefore the ducting is a lot smaller. But the problem is static pressure. You can only put so much duct, limited amount of duct on these things. But the efficiency is the same. The efficiency is no different. Whether it's central, ductless cassettes, or concealed ducted um, um, fan coils. However, you're delivering that heat or cooling into the building is not going to impact the efficiency, because the efficiency is about how the technology of the heat pump is. You know, the COPs, or heating season performance factors, is not going to change downstream of that, of the heat pump. It's the only difference in efficiency is how efficiently, sorry, you're delivering the comfort, right? That is completely dependent on how well designed and executed the system is.
Great. Okay, thanks, Robin. Thanks for staying a couple minutes over time.
Oh, no problem.
Folks, go ahead if you do have any questions left, go ahead and pop them in the chat there, and we'll follow up via email. Thanks everyone for joining us today. Our next webinar is on April 17th, and it's around commissioning and performance verification of heat pumps. Check out the follow-up email for links to the registration there if you haven't yet registered. And thanks again, Rob, for sharing all of your wisdom and knowledge with us.
Well, thanks for the opportunity. Great questions, and I'll be happy to follow up with any questions by email or whatever.
Perfect. Thank you.
Thank
All
you
right.
very
Thanks,
much.
everyone.